Welcome to Mythbusters Physics Edition. Welcome to our channel. Today we're diving into the world of physics to debunk some of the most common misconceptions. From the depths of space to the intricacies of our own planet, misconceptions about physics abound. But fear not, intrepid viewers. We're here to equip you with the knowledge to navigate these cosmic falsehoods. Let's get started. You've heard the claim, the Great Wall of China is the only human-made structure visible from space. It's a statement that evokes a sense of awe, a testament to human ingenuity. But is it true? Well, buckle up, because we're launching into orbit to find out. The truth is, from low Earth orbit, where most astronauts reside, the Great Wall is practically invisible. It's a matter of perspective. Imagine trying to spot a strand of hair from across a football field. That's the challenge astronauts face. Plus, the Great Wall's materials blend in with the surrounding landscape, making it even harder to discern. Lightning never strikes the same place twice. This old adage is often used to downplay the likelihood of a rare event happening again, but in the electrifying world of physics, this couldn't be further from the truth. Lightning doesn't play favorites, and it certainly doesn't keep a list of past targets. Tall structures like skyscrapers and trees are prime targets for lightning strikes. In fact, the Empire State Building gets struck by lightning dozens of times a year. Why? Because lightning follows the path of least resistance, and these towering structures offer a convenient shortcut between the storm clouds and the ground. Have you ever heard that water swirls down the drain in opposite directions in the northern and southern hemispheres? It's a popular notion, often depicted in movies and TV shows. This swirling phenomenon is attributed to the Coriolis effect, a real force caused by the Earth's rotation. However, the Coriolis effect, while real, is far too weak to influence the direction of your draining water. The direction water spins down the drain depends on factors like the shape of the sink or tub and the initial motion of the water, not the Earth's rotation. Chapter 4. 10% Brain Myth. Unlocking Your Full Potential. The human brain is often compared to a powerful computer, capable of incredible feats of processing and storage. But a persistent myth suggests that we only use a measly 10% of this remarkable organ. The truth is, we use our entire brain. Every region, every fold, every neuron plays a role in our daily lives. Brain imaging techniques like fMRI reveal that even simple tasks like talking or walking engage multiple areas of the brain. We may not use all of our brain power at once, just like we don't use all of our muscles at once, but that doesn't mean those unused portions are dormant or unnecessary. Chapter 5. The penny drop terminal velocity versus urban legend. Imagine this. You're strolling through Times Square when suddenly, a penny plummets from the top of a skyscraper, gaining speed with each passing floor. Could this tiny copper projectile really spell disaster for an unsuspecting pedestrian below? It's a classic physics conundrum, but the answer might surprise you. While a penny dropped from such a height would certainly gain significant speed, it wouldn't reach the kind of velocity needed to be lethal. Air resistance, often neglected in idealized physics problems, plays a crucial role. As the penny falls, air resistance increases, eventually counteracting the force of gravity. This balance of forces results in a constant speed, known as terminal velocity, and for a penny, that speed is far too slow to be deadly on impact. Chapter 6. Gravity's Grip. Debunking the zero-gravity myth. We've all seen footage of astronauts floating effortlessly in their spacecraft, seemingly free from the constraints of gravity. It's easy to assume that they've escaped Earth's gravitational pull altogether. But hold on, there's more to this story than meets the eye. Astronauts experience what's called microgravity, not zero gravity. They're still very much under the influence of Earth's gravitational pull, but they're in a constant state of freefall. Imagine yourself on a roller coaster as it plunges down a steep drop. That feeling of weightlessness is akin to microgravity. Chapter 7. Tilted Earth. The real reason for the seasons. As Earth embarks on its annual journey around the sun, we experience the ebb and flow of the seasons. But why do we have these distinct periods of warmth and cold? You might be surprised to learn that it's not Earth's distance from the sun that determines the seasons. The Earth's axis, an imaginary line passing through the north and south poles, is tilted at approximately 23.5 degrees. This tilt, not our elliptical orbit, is the key to our planet's diverse climate zones. During summer in a hemisphere, that hemisphere is tilted towards the sun, receiving more direct sunlight. In winter, the opposite occurs. Chapter 8. Black holes. More than just cosmic vacuum cleaners. Black holes, enigmatic objects of immense density, are often portrayed as cosmic vacuum cleaners, relentlessly sucking up everything in their path. But while their gravitational pull is undeniably strong, they're not the insatiable monsters they're often made out to be. Black holes warp the fabric of space-time, creating a gravitational well so deep that nothing, not even light, can escape once it crosses the event horizon, the point of no return. However, objects can orbit black holes stably, much like planets orbit stars. They don't get sucked in unless they stray too close. Chapter 9. The Moon's Two Sides, Unveiling the Truth About Tidal Locking. Our celestial companion, the Moon, presents the same face to Earth night after night. This has led to the popular misconception that the Moon has a dark side, a hidden hemisphere perpetually shrouded in shadow. But fear not, lunar enthusiasts, for the truth is far less mysterious. The Moon is tidally locked to Earth, meaning its rotation period is the same as its orbital period around our planet. Think of it like a dance where one partner always leads and the other follows. In this cosmic waltz, Earth takes the lead, dictating which face of the Moon we see. Chapter 10. Silent Space, Debunking the Sound Barrier. In the vacuum of space, no one can hear you scream. It's a classic movie tagline, and for good reason. Sound, unlike light, needs a medium to travel, like air or water. In the vast emptiness of space, there's no air for sound waves to vibrate. Sound waves are vibrations that travel through a medium by compressing and expanding the matter within that medium. Without matter, there can be no sound. So while the universe is filled with awe-inspiring sights, it's a silent symphony, a cosmic opera performed in complete silence. Outrow, keep exploring the universe of knowledge. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating science content. Remember, the universe is full of wonders waiting to be explored, and sometimes the most common beliefs turn out to be the most inaccurate. Keep that spirit of curiosity alive, and never stop questioning the world around you. See you next time.